This is video 5, and I'm sorry about the abrupt ending of the last video. I actually got a phone call that ended it, and there was no way I was re-recording the whole thing. I'm sure y'all can understand. So let's quickly go back to what we were doing. We are now going to do the check it out on page 323, and we're going to be doing the same thing we were just doing except for using this diagram instead. So the first thing we're going to do is try to find out what JL is. Let's find JL in here. It's this long line. Well, according to our theorem, if we have a mid-segment, which we do, we can tell that that's a midpoint because those are congruent, and we can tell that's a midpoint because those are congruent. Therefore, PN is a mid-segment, and we know that it's half of the line it's parallel to, which is JL. So if PN is 36, then JL will be pretty easy to figure out. It's just going to be 36 times 2, which is 72. So that's our answer for that one. The next one is PM. Let's look for PM. Here is PM. Okay, so you're looking at this and you may be thinking, well, how in the world are we going to use that? You've just got to shift your eyes in the angle that you're looking from at this triangle and realize that that also is a mid-segment and that this is its base. So we have midpoint. We can tell that by the congruencies on the sides of it. We have this midpoint, and we can tell it because of the congruencies on the side of it. So MP is in fact a mid-segment, and it's going to be half as long as the base below it, which is LK. If LK is 97, then half of it for MP is going to be 48.5. I hope that math is correct. That's what I did in my head before the video. And the last one is the measure of angle MLK. And that is right here, MLK. Okay, now I have to try to I had to try to remember how I got that answer. That one took me a few minutes. So I really had to brainstorm on that, and that's what this is going to take for you. It always takes brainstorming to put together the puzzle pieces. But what you need to see is that we have two parallel lines right here. And we have two parallel lines that are crossed by a transversal. That ML is their transversal. And when two parallel lines are crossed by a transversal, we have same side interiors. Remember, same side interior angles are supplementary. When two parallel lines are crossed by a transversal, same side interior angles are supplementary. So we knew right above here that if this angle is 102, then this angle had to be 78, just because that's a linear pair or a straight line. So 102 plus 78 is 180. Once we knew that, we could do our same side interior angles, and if we knew 78, we knew that 102 took us back to 180 for supplementary angles. That's one option of knowing that MLK, angle MLK, was 102 degrees. Our other option there was to see that this angle and this angle were actually corresponding angles. So that's another reason that the bottom angle is 102 degrees. All right, let's look at one more quick example right here. And this is, I'm going to show you the picture and I'll read you the problem. This is example 3. Anna wants to find the distance across the base of the volcano, an extinct volcano in New Mexico called Capulin Volcano. She measures a triangle at one side of the volcano, being this above side, as shown in the diagram. What is AE going to be? Well, this is no different than what we've been doing. This is an application of the mid-segment theorem. We know it's a mid-segment because we see that 920 and 920 are congruent, and we see that 700 and 700 are congruent. So therefore, we know that we had midpoints connecting a mid-segment, and that mid-segment, remember the theorem, is going to be half of the length of the side. So 775 is half of 1,550, and that's going to be our final answer.